I will introduce the last speaker today, and the last speaker is Dr. Merhat Bastani from Swedish Geological Survey, yeah. And Dr. Bastani got his PhD from Uppsala University with a focus on arithmetic methods, and he is working in Geological Survey of Sweden as a senior geophysicist since 2001, and he will give his presentation on integrated modeling of geophysical and petrophysical data for imaging deeper crustal structures in northern Sweden. You're welcome, Dr. Bastani.
Thank you very much for the presentation, and good morning, everyone. Before I start my talk, I would like to acknowledge the work done by my colleagues, Ildiko Antal Lundin and Johan Jan Berger from Geological Survey of Sweden, or SGU, and also Shungu Wang from Uppsala University. This study is about part of a bigger mapping project SGU carried out between 2012 and 2015. So this is the study area where you see this 74 kilometer seismic line we measured in 2012, and the area is highly rich in zones with mineralizations, and in 2014 we carried out some empty measurements at these locations to come with some more information about the variation of the electrical conductivity of the ground, and also make some 3D inversion of the data we have in this area. And the main idea was to provide modern information, both geophysically and geologically, to the mining industry in the area. So the data we have used for our inversion and modeling is airborne magnetic, which we see here. The data is collected by this mining company called EAGE, and at the bottom we see the ground gravity data collected by SGU. We collected empty data at those stations and used the remote reference technique to process the data. And as you see, it was quite difficult to dig in this hard environment, but we did all these measurements in 2 weeks. The data quality, it was quite good since we used this remote reference technique by the code developed by Smirnov, 2003. The reflection seismic data was collected in the collaboration between SGU and Uppsala University. There they used different type of sources. Sorry. This bib size, and also they used dynamites that LKAB helped them to carry out this type of measurements. And then for the 3D modeling of empty data, we use the code WSINV3D empty developed by Siripon Varaporn et al. 2005. And also we used WAXI, which is a part of OIC's montage to model the gravity and the magnetic field data. Here you see the results of this 3D modeling, density, contrast, susceptibility, resistivity. And then we thought the best thing is to compare the results along the sections along seismic lines. Maybe they are not so clear here. I will show it in the next picture. Here we have these seismic lines, and you see the empty stations. And we have selected, I have selected in this presentation 3 sections to compare different models. So here you see section 1. We have the susceptibility model, the resistivity model, and the density contrast model. what we tried to do, we use this white arrows to indicate the shallower structures, which we see most dominant on the susceptibility model. And as you see, below the depths of 3 kilometers, we don't see any variation in the susceptibility model. So those more shallower structures, they have a good correlation with the density contrast model, but we don't see much correlation within the resistivity model. And if you look at the deeper structures, which we took from the density contrast model, they fit better to the resistivity model, and we don't see much in the susceptibility model. Going forward to sections 2 and 3, which are here, we see the same type of correlation between the models, but what is very interesting here, we have a very long deformation zone here, and to the east of that deformation zone, we see a big change in the resistivity model. And if you look at here, to the east, there are also a lot of mineralization zones of different type. And also we see a very big difference in the density model here to the east. Comparing to the seismic data, it was not so easy for me to that because I am not expert. What we did, we took some of this, let's say, reflectivities here on the seismic data and try to compare it to the susceptibility and the density model. At the surface, we see quite good correlation between the reflectivity and the dips with the susceptibility model, but not much at the deeper parts. So comparing the 3D resistivity model with some of the mineralization zones, we thought it was interesting. Here we see the geological map and the 3D model down to 10 kilometers. And we looked at the mineralization database. Here we have a lot of graphites, and we see a very conductive zone in the empty resistivity model. Another example is this area here. And if you look at the information in the database, it's sulfide mineralization, so it can be quite low resistivity. And the same here, we see sulfide mineralization, very low resistivity. And in that part, we don't have any information about mineralization, but we see a very low resistivity zone, and we don't know what it is. I tried to look at the borehole data. Unfortunately, we don't have that many deep boreholes, so we selected this very small area to look at some shallower information to see how well we can see it in our models. I looked at the very old reports at SU. It's from 1982. It's the map of the area you find in that report. And then the reason for that was that there were a lot of information about the boreholes in the area. So this is a more modern map of the same area. Here we have it. And then we looked at the borehole information. There are quite many boreholes here. And then we looked at our data sets. Here you see this graphite horizon. It's given there. And it's a borehole. And also the other two boreholes here. You see the graphite zones here. And this is the borehole direction. So they are pretty shallow, but they're dipping. And what we did, we looked at the existing data. It's quite intensive or dense magnetic data that LKAB has collected on the ground. And I don't know if you see these small circles of yellow color where they have taken petrophysical samples. This is the data you see. So it's a good ground to do some forward modeling. of the data. So what my colleague Yuan did, he made a forward modeling of the potential field data using all those petrophysical data. And at the same time, along this small line, he made a VLF measurement where he could make this resistivity model using a 2D inversion code, Reebok. So comparing this information with those that we have from the old report, we see here at these 2 points they have found graphite mineralization, which quite correlates very well with these very low resistivity features in the model. And then if we just overlap this information on the place, it fits quite well with the anomaly we see on the resistivity data. So as conclusions, the MT data are of good quality, what we have collected, and they have considerable Eclipse penetration. The susceptibility models, they give the best resolution at the surface, and at depths we have found the correlation between the density model and the resistivity model. And the resistivity models, they image conductive structures that correlate well with known mineralizations. And for the outlook, we need to do 3D joint inversion of MT and magnetic. Although Alan Jones mentioned yesterday that it is a problem to use that code that Maxim Moorkam has for joint inversion of MT and mag. And then we have to use seismic information to make a constraint inversion. We certainly need more shallower information of the resistivity, so we have to do the stem measurements to have a better resolution at shallower depths. And we suggested a borehole there down to 2 kilometers to see what this very high conductivity feature we see in the MT data is. And thank you for your attention and all those who helped us with the field measurements.
Thank you.
Yeah.
Thank you. Thank you very much. And we have time for questions, please. Yeah. Maybe walk to the microphone if possible. Yeah.
Were those susceptibility measurements made on outcrop with susceptibility meters, or were they actual samples collected? And
They were actual samples that they were collected.
so were there remnants measurements made as well as the susceptibility?
Yes, we usually do that.
And can you say something about the procedures that are used when measuring the remnants? Is there paleomagnetic cleaning done on the samples and so on?
I am not quite sure because I am not involved in that measurement, but I am sure that they do a proper work to measure that.
All right, thank you.
I have follow-up questions. So inversion was for susceptibility only. You didn't run for remnant monetization.
No, in WAXI it's not that easy to do that.
Yeah. Okay. Any other questions?
Yes.
Yeah, please.
Don't you have EM surveys down over there? Airborne EM surveys from
We have airborne VLF and a little bit of slingram data, but it's just the airborne slingram, let's say airborne frequency domain. And it's just a single frequency. It does not have that much of resolution, unfortunately.
So you don't have much information?
Airborne is just the VLF and this single frequency domain. Yeah, with this airborne VLF, we see some of the structures, but since the VLF data is very old, it's just from one transmitter. So it's highly affected by the direction of the transmitter, so we don't see that much.
Okay, yeah, more questions, please?
In this specific case, or I think it's about 1,000 at least, even more. Yeah, we have a big database from the entire country. In fact, it's 59,000 samples.
Okay, any? Please, yeah.
The inversions that you showed, the susceptibility inversion,
So what we did, we set petrophysical constraints, as we can do in WAXI, based on the susceptibility measurements we have in the lab. So we put a higher level and a lower level that we don't allow that inversion exceeds that value. This is the way we used it. But that, as I discussed with you, I would like to make, let's say, depth weighting with the inversion. And for that, we need to make a maybe voxel for that.
Okay, thank you. Any other questions? I don't. Oh,
There's one.
one more. Okay, please.
Yeah, I didn't put any limit. It's the output of the inversion. You don't see any variation below that depth with a good fit to your data. No, maybe it's not in the data. You don't have, because below these rocks, we have Archean rock, which has no susceptibility. And I think it belongs to that Archean rock, that susceptibility, at least in that part of the profile.
Okay, thank you. No, I think that with this we will conclude. Thank you very much again.
Yeah, thank you.
And I would like to thank all participants for being here, and also to thank all speakers for presenting their talks, and thank you very much again for participation.